Good morning. Just a reminder to you that you have the ability to fast forward or pause the video. If you need more time to write something down, please do that. And if you want to rewind to make sure you caught what I said and you want to make sense of it, you're more than welcome to do that as well. If you're somebody that wasn't in class today, we started a note-taking strategy called Cornell Notes. I'm going to be passing out the sheets for you to take notes on from now on. But if you don't have those sheets and you were absent today, you can just take the notes on your own paper and then make sure that you have them to do the assignment that is linked to the calendar. If you do not have the worksheet, you can print it, or you can put the answers on your own sheet of paper and turn your own sheet of paper in tomorrow. Okay, so filling out the top of the Cornell Notes sheet, I would like you to write the topic or objective. So we are in Module 6 right now, and we're going to be talking today about ion formation. So the topic is ion formation, and this is Lesson 1. Would you also fill your name in? Would you write chemistry for the class and the period number? And then I also need the date. It's 2/1/2023. And then there's an essential question that you're supposed to fill in. I have it listed as a focus question in the slideshow, but the question is, why do elements form compounds? So please fill that in as the essential question. And hopefully at the end of this lecture today, you're going to understand why an element would want to form a compound with another element. These are some new vocabulary that you guys are going to learn. You're going to learn what a chemical bond is, a cation and an anion. You don't need to write those down right now because you'll be writing them down later. So here's some review vocabulary. And you definitely can write this down if you need to, if you don't remember it, but it's the octet rule. If you know anything about Cornell Notes, there's a left-hand column where you guys can write down terms so you can quickly find them, or you can write questions there if you have them. So the octet rule, if you remember, is that atoms tend to lose, gain, or share electrons in order to require 8 valence electrons. Okay, my next term is a chemical bond. So a chemical bond is a force that holds 2 atoms together. So you guys, when a compound forms, you have 2 atoms that are stuck together, and what's holding them together is this force that we're going to call a chemical bond. Chemical bonds form because there's an attraction between one of these 2 sets of things. There's either the attraction between the nucleus of one atom and the electrons of a second atom. And if you guys think about it, the nucleus has protons in it. Those are positive, and they are attracting the electrons from another atom. So that's one way that a chemical bond can form. That's one way the attraction can form. The other way that the chemical bond can form is if there's an attraction between positive and negative ions. We talked at last module, how positive and negative ions form. Positive ions form when atoms lose electrons, and negative ions form when atoms gain electrons. So a chemical bond can form when they attract to one another because of those opposite charges. Okay, nothing you need to write down about this, but you guys, what we can do is we can show chemical bonds by using electron dot structures. So you guys are going to need to kind of refresh your memory on how to do an electron dot structure. There's nothing you need to write down in the notes, but when you do the worksheet later today, you're going to be asked to do some dot diagrams. Just a quick reminder that when you do dot diagrams, you always start over on the right, you pick top or bottom, and then you work your way around counterclockwise. Beryllium's dot diagram here, not really done the correct way that I would prescribe you to do it. There should be 1 dot on the right side, top or bottom, and 1 dot on the top, either left or right, okay? When you look at carbon here, doesn't really look like they made a choice whether it was top or bottom, left or right. But remember, your first dot should be on the right, top or bottom. Second dot, top, left or right. Third dot, pick a top or bottom. And fourth dot, pick a left or right. Okay? Okay, let me erase this quick from the last slide. Okay, we've got two terms here, ionization energy and electron affinity. Remember, sometimes people use the left column on their Cornell notes to list terms, and then they can find them quickly when they want to look through their notes. Ionization energy, if you remember, is the energy required to remove an electron. I'm going to simplify that definition as how easily an atom loses electrons. Electron affinity is kind of the opposite. Electron affinity is a measure of the attraction an atom has for electrons. If you think back to the last lesson that we had, Module 5, Lesson 3, they used the term electronegativity. Electronegativity was a measure of an atom's attraction for electrons. Electron affinity is very similar. It's how much attraction an atom has for electrons. They're almost interchangeable. So you guys, when you think about it, noble gases, we're going to use these as an example. We want to talk about their ionization energy, how easily they want to lose electrons, how easily they will lose an electron. And we want to talk about electron affinity, how much attraction an atom has for electrons. So when we think of noble gases, they are going to have a very low electron affinity. And the reason for that is they don't want to attract electrons. They already have 8 valence electrons, or 2 in the case of helium. They don't want to attract electrons. So they have a low attraction or a low electron affinity. When you think about ionization energy, that's the energy required to remove an electron. Well, they're noble gases, they're stable. They're going to have a very high ionization energy. It's going to be very difficult to remove an electron from a noble gas. Okay, I need you guys to think of the alkali metals. You might want to take a periodic table out where you look at the alkali metals quickly, and you may want to pause the video and ask yourself about the ionization energy and the electron affinity for alkali metals. Are they going to be high or low? I'll let you pause the video and then come back. Okay, hopefully you thought about it. Alkali metals, they're in group 1. They have 1 valence electron, and what they do to become stable is they lose that 1 valence electron. So because they don't want electrons, they're going to have a very low electron affinity. Alkali metals, they have a low attraction for electrons, a low electron affinity. And then, you guys, their ionization energy is also going to be low. They want to lose electrons. Ionization energy is how easily an atom loses electrons, and they're going to want to do that. So they have a low ionization energy. I'm going to erase this and we'll go to the next slide. Okay, noble gases, some things that you need to know about them. Try to convert these to memory. They have electron configurations with a full outer energy level. Okay. They are stable with 8 valence electrons, and they're unreactive. The reason they don't react with any other elements is because they already have 8 valence electrons. You guys might remember the lab we did early in the year with the plastic bag and the 4 chemicals that we put in there, and we had color changes, temperature changes, gases being produced. And the reason that we have that reaction going on is the elements that are in that bag, the little atoms, they are scrapping for electrons. Okay, so they are very reactive. The noble gases, they don't react with anything because they're stable with 8 valence electrons, except for helium. But if you look at the first bullet here, it explains helium. Helium is a noble gas because it has a full outer energy level. Helium ends with 1s2, okay? That's the first energy level. Helium fits the bill of a noble gas because it has that full outer energy level. Okay, all other elements then, you guys should understand that they're going to be reactive. So all other elements, they're going to react to acquire the stable configuration of noble gases. They want to look like noble gases. We call this a pseudo noble gas configuration, a false noble gas configuration. And in order to do this, they follow the octet rule. And if you guys remember the octet rule, they will lose, gain, or share electrons in order to get 8 valence electrons or a full outer energy level. Okay, we want to talk a little bit about positive ion formation. Positive ions form when atoms lose electrons. You guys should remember that. And positive ions are called cations. Okay, so whenever we have a positive ion from now on, let's say we have like calcium +2, you can't call it the calcium just ion. We want to call it the calcium cation. I had trouble remembering this, so I always remember that cats have paws, so cations are positive. Okay? So anytime you lose electrons, you form a positively charged ion, and you're called a cation. Okay, I want you to put this example in your notes. We're going to take a look at sodium. Sodium is element number 19 on the periodic table. I think it's 19. Nope, I'm wrong. Sodium's element number 11. We're going to write out the electron configuration. 1s2, 2s2, 2p6, 3s1. I'm going to neaten that up a little bit. 1s2, 2s2, 2p6, 3s1. If you take a look, sodium has 1 valence electron. It's not stable. So what it's going to do is it's going to lose that 1 valence electron. It's going to ship it off someplace else. It wants to get rid of it. And what we're going to end up with is still sodium. It's going to have 11 protons still, but now if we rewrite the new electron configuration, we can see that in the second level, it's got 8 valence electrons. The problem is it lost an electron, so you have to be careful and put a little positive charge up in the air above sodium. So let me see if I can get my eraser in here. Erase both my sodiums. This guy was sodium 11. This guy lost an electron. He now has a little positive charge up in the air. Should look more like this, but my board's a little off. Na+. Over here on the right side, if you come over here, we can see why it has a positive charge. Sodium started with 11 electrons and 11 protons, but when it gives away an electron, now there are 10 electrons and 11 protons. There's more protons. That's how it gets the plus charge. I'm going to erase this. You guys should know that it's metals that form the positive ions. It's going to be metals. That's something you need to memorize. You may want to take a little look at the chart, but it says group 1 and 2. That's the alkali metals and the alkaline earth metals. And group 13, but only the metals in group 13. Remember, metals are to the left of the staircase. They're all going to form positive ions. The transition metals, they will form positive ions as well. And we'll talk about those at a later time. Okay, let's talk about negative ion formation. Pretty simple. Negative ions form when atoms gain electrons, and they're going to be called anions. So you need to know that when you see a negative ion, like N-3, and it doesn't matter whether you do N-3 or N3-, it's still a negative ion, it's going to be called an anion. So negative ions are anions, and they occur because an atom gains electrons to become like a noble gas. Let's take a very quick look at this, an example. And over on the right, they're using chlorine as the example. So we're going to quickly write out the electron configuration for chlorine. It's element number 17. Maybe you want to pause the video and do that just to practice, because you're going to need to be able to do this. But it's 1s2, 2s2, 2p6, 3s2, 3p5. If we count the valence electrons, it has 7 valence electrons, not 5, 7. We count all the 3s. So it needs to gain an electron to have 8 valence electrons. So what's going to happen is we are going to gain 1 electron from another atom. So if we rewrite that electron configuration, we're still chlorine element number 17, but now we're 1s2, 2s2, 2p6, 3s2, 3p6. We've gained an electron, and now we have 8 valence electrons. But we have to be careful. You've got to put the little negative up in the air now. It's a 1 minus charge, Cl minus, because you've gained an electron. If we take a look over here on the right side, if you take a look over here, you guys can see that the neutral chlorine atom has 17 protons and 17 electrons, so they're equal. But you guys, to become stable, we gained an electron, and we have 17 protons. We've got more electrons. That's why we end up with the negative charge. And you guys can write negative or 1 negative or minus 1, either way, but you have to show that it has a negative charge. Okay, hitting the home stretch here, almost done. Hopefully these videos will get shorter as I get the hang of this. I would write down that nonmetals form negative ions by gaining electrons. It's going to be nonmetals. Remember, the noble gases aren't going to do this because noble gases already have 8 valence electrons. And then the last thing I've got is naming ions. So positive ions, and you guys have to remember that positive ions, they're called cations. And to name them, all you do is name the element plus the ion. So both of these here, here, and here, those are positive ions. In order to write their names, all I do is name the element. So here we have sodium. And all I do is add ion. So that's the sodium ion. We don't change the names of positive ions. And then with aluminum, it's still a positive charge. It's a cation. We're going to call that the aluminum ion. Hopefully that makes sense. Okay, over here with negative ions, those are called anions. So with negative ions, you change the ending of the element to "ide," the suffix "ide," and then add the word ion. So if we look at this one, Cl minus, notice that it has the minus. It's an anion, it's a negative ion. So we change the ending of chlorine to "ide." So we're going to call it the chloride. Okay, we change that ending, and ion. Okay, over here, we've got N3 minus, it's negative. That's nitrogen. But the negatives, we change the ending. The anions we change. So we're going to call that the nitride. Change the ending to ion. Remember, the positives, we don't change. You have a worksheet that's linked to the calendar that's due tomorrow. Let me know if you have any questions. And thanks for watching the video.